Good afternoon, everyone. Today we're going to do an example where we find the surface area of what we have for a composite object here is a cone topped up with a hemisphere on top, kind of like an ice cream cone. Okay, so when we look for the surface area, we have to consider what surfaces we actually have to look at, right? When we have our cone on the bottom, we know that we're not actually going to find the area of the circle that tops it up, because that circle is covered by the hemisphere. Okay, to get the area of the circle and then have to subtract it later on because it's being overlapped is more work than it needs to be. So I would rather simply consider the fact that we don't need the area of the circle at the top of the cone, we only need the area around the cone, that is the lateral area of the cone. And so let's start off with our first formula. We know that the lateral area of a cone is measured by pi times its radius r times its slant height s. So our first order of business is to look whether we have all of those pieces. We have the radius being 4 inches, certainly. The radius is the distance from the center to the side, but we only have the vertical height over here for 10 inches high, but we don't have the slant height, or we don't have the slanted height on the diagonal over here. We do have the vertical height and we have the radius of 4, and so we can see that naturally a right angle triangle takes shape, right? And anytime we can find a right angle triangle in our diagrams, we usually know that means using Pythagorean theorem. And so we are looking for our slant height s, which will act as the hypotenuse of a right angle triangle. We have the two shorter legs, the height and the radius, and so we can go ahead and find the slant height. Know that s squared is equal to 10 squared plus 4 squared. Right, and you guys have seen this before. S squared is equal to 100 plus 16. And so S squared is equal to 116. And now our algebra tells us we have to do the square root of both sides to cancel out the square on the S. And so we have that S is the square root of 116, which I believe is roughly 10.8 to 1 decimal place. Okay, so now that we have our slant height, we can get the lateral area of the cone. The only other part of this problem that we have to consider is the surface area of the hemisphere, just the top side, right? Again, we won't need to look at the area of the circle at the bottom of the hemisphere because that's going to be crunched into the cone, right? We're not going to see inside of the cone and the ice cream scoop, right? So we can ignore this circle kind of in the middle altogether, okay? So we have the hemisphere on top. Now I'll remind you that the surface area of a full sphere is 4 pi r squared. That is if we had a full sphere. So naturally the surface area of a hemisphere, again without considering the circle at the bottom, because we won't really be looking at that. It's going to be covered by the bottom cone. So the surface area of just the outside of the hemisphere is half of a full sphere, and so that's 2 pi r squared, okay? And now we're almost done. We have the lateral area of the cone being pi r s. That's going to be the curvature around the cone, and we have the surface area of the hemisphere that tops it off. And so now let's put all this together. So we'll have our surface area total being pi r s plus the hemisphere having a surface area of 2 pi r squared. I like to write out my formula with the variables still in it just to begin my solution, and then we can plug in our values. We know that r, the radius, is 4, s we found to be 10.8, and that's all we need. So let's go ahead and do that. Pi times 4 times to 1 decimal place 10.8 plus 2 times pi times 4 squared this time. And now we can calculate that. You guys can go ahead if you would like. I'm going to do this without rounding in between. So I'm going to leave pi outside. I'm just going to multiply through by all the numbers, and then I'm only going to round at the very last step. If you round all along the way, just be mindful that our answers might differ a tiny little bit in the end. So we have 10.8 times 4 plus 4 squared is 16 times 2 plus 32, and now we have pi in both, so we can multiply that by pi times pi, and we get a total surface area of 236.2. Let's just keep things to one decimal place, and to the nearest tenth of a square inch, because we have surface area, which is two-dimensional, as the 2 on the exponent. And there we go, okay? I hope this helps. I hope this starts to make some connections between the different formulas that we typically use for surface area problems, composite object. Again, I don't recommend getting the area for any surfaces that are overlapped, just because it tends to make our solution a bit messier than is necessary. And I'd rather encourage my students to kind of take the time to think of what surfaces are actually at play, given the situation they find themselves in. So, I hope this helps. Thanks for watching, and have a great day.